Okay, question 9 on the June 23 paper 1 Edexcel A level. We're looking at geometric sequence, although this is to do with geometric sequences. So what we need to remember here, a geometric sequence is one that has a common ratio. It's being multiplied by the same value every single time. So to work out for part A, it says show that K satisfies this equation. Well, what we know is then that divided by that will be the same as K plus 16 divided by 12 minus 3K. So let's write that out first. So 12 minus 3K divided by 3K plus 4 has to be the same. So whatever that's been multiplied to get you there will have to be the same as this value here. So if I do K plus 16 divided by 12 minus 3K, and once you've got that, you can cross multiply to simplify it. So we've got 12 minus 3K times 12 minus 3K equals 3K plus 4 times K plus 16. So let's expand and simplify. Expanding this out, that gives us 144 minus 36 minus 36, so minus 72K, and it's going to be plus 9K squared. On this side, 3K squared plus 48K plus 4K, so plus 52K, and then plus 64. And simplifying that all to one side, you've got 9K squared here, so let's do it on this side. 9K squared take 3K squared gives us 6K squared. You've already got minus 72K here. We need to take away another 52. That gives us minus 124K. And you've got 144. You need to take away 64. So that gives us plus 80 equals 0. So we're almost there to that one. You can see all you need to do is divide through by 2, and that gives us 3K squared minus 124 minus 62K plus 40 equals 0. And that is what we were looking for. We can write QED, that which was to be proved. Now for part B, part 1 says find the value of K giving a reason for your answer. So in order to do that, we need to solve this equation. So 3K squared minus 62K plus 40 equals 0. To solve that, we get two answers. We get K equals 20 and K equals 2/3. Now, could they both be correct? It says find the value of K giving a reason for your answer. So chances are they're not both valid. So let's check with each one. If K equals 20, our sequence will be 64 minus 48 and then 36. So what's our common ratio? It's being multiplied by minus 3/4. If K is 2/3, our sequence will look, so 3 times 2/3 plus 4 will give us 6, then 10, then 50 over 3. And here our common ratio is 5 over 3. Now, remembering here, given that the sequence converges, because it converges, that means R, or the magnitude of R, has to be less than 1. So for this one, minus 3/4, this one is valid. This one would, however, because it's greater than 1, it won't converge, therefore invalid. And it's worth just stating here again, because the sequence converges, the the magnitude of R has to be less than 1. So it can be plus or minus 1. And that's why this one is valid, and then this one would be invalid. So therefore, R equals minus 3/4. And it is important to make sure that you're very clear and you've explained why in order to get your marks there. And the last part then, for part 2 of B, find the value of the sum to infinity. And remember here in the formula booklet, you don't need to memorize this. They tell you that the sum to infinity equals A over 1 minus R for when the magnitude is less than 1. So in this case, we've already worked out, we're looking at this sequence here. Our first term, so A is 64, first term, and our common ratio was minus 3/4. So I need to do 64 divided by 1 minus 3/4. Be careful with your negatives there. When you work that out, that gives us 256 over 7. And that is what our series will converge to.